Okay, so yeah, thank you all for coming. So I'm really excited and happy to have Charlotte as our speaker again, and also really happy and excited to have Sabrina as our speaker too. So before we get started, please let me do some introduction. Okay, so Charlotte is a current grad student born in the Pacific Northwest, where the dark skies fuel the passion for astronomy from an early age. This passion has turned into a full-time pursuit of hunting down how galaxies acquire their stellar mass over each galaxy's lifetime. In addition to the love of galaxy evolution, Charlotte is also committed to mental health awareness, gender equality, racial justice, disability rights, decolonization, and generally all movements which lessen human suffering and increase self-determination for marginalized groups. And Charlotte also likes garage rock and 60s French pop music, comic books, vintage arcade games, digital watches, running, abstract art, walking their dog, spending time with their wife, and the occasional gym tonic, which I also like. And let's turn to Sabrina. And Sabrina is a third-year grad student working with Professor Blexley Burkhardt on understanding how stellar feedback processes impact star formation. In addition to research, she's dedicated to learning, mentoring, and working to improve the experiences of underrepresented and marginalized groups in physics and astronomy. In her free time, she enjoys music, ballet, reading, and knitting. So yeah, on a side note, which I might mention before, just when I was organizing SBAR in the summer, I kind of asked several faculty members, like, can you suggest me some students that they might think just suitable to give us a talk on inclusion and equality related topics? And yeah, well, univocally, they just suggest me to contact Charlotte and Sabrina. So yeah, way to go, Charlotte and Sabrina. So yeah, without further ado, please take it away, Charlotte and Sabrina.
Okay, I'm gonna screen share, and then I'm gonna let Sabrina, if you want to start, and then also if you can keep half an eye on the chat.
Yeah, so I'll keep an eye on both the chat and the participants list. So if you have questions or comments or anything along those lines, feel free to pop them in the chat or raise your hand or chime in. Obviously, the first part will be recorded. So if you would like to discuss things that you would prefer were not on the recording, we will make sure there's time at the end for that.
Just a second, I lost the...
It's okay. Also, I think this is the third time we've given a version of this talk. So if, for some of you, this may be familiar from previous years. Yeah, so we're going to talk about women in physics as a case study of equity issues in physics. So let's go to what's our next slide? Yeah, so we want to start with a quick disclaimer, and that is, 4 things, not 3 things, but whatever. First of all, we have our own limitations and perspectives. We cannot represent everyone, and we may well mess up. We will do our best, but we want to make sure you're aware of that. Also, please speak up if you have another perspective to share. And of course, this may be uncomfortable for any number of reasons. So make sure that you're taking care of yourself, but also please take this seriously and don't check out just because it isn't fun. Our aim here is to present valuable perspectives which may be different from yours, and we will draw on both multiple studies and the real lived experiences of our colleagues. So we ask that you keep that in mind and be respectful of these stories that we are going to be sharing with you.
Come on, there we go. Okay, so we're going to go through a couple of different things, like, we're going to talk about things broadly, and then we'll talk about a couple of studies. And we have numbers for those, which that's always nice. Then we'll talk about some solutions and ideas to address these problems. And then the last part is when we will probably turn the camera off and we will go through a few scenarios and kind of talk about, how we personally would deal with this. And these ideas apply broadly. We're basically we're focusing on women because it is the most studied group in our particular field. So, oh my God, all right.
So first of all, why should you care? I mean, by filtering out people based on gender, race, ethnicity, or any other personal attribute, we're losing brilliant minds who could be contributing to the field. So, you know, who doesn't want to double the number or, you know, more than double the number of brilliant physicists that we have working on these problems? Stagnating statistics report that the number of women in physics are the canary in the coal mine of equity issues in physics. So, for example, women are more or less 50% of the population, but less than 20% of physics graduates, graduates, I should say. Most of these 20% within the US are white women, and of those women, very few remain in the field for very long. Also, all of these things that we're going to talk about today have a huge impact on the mental health of underrepresented groups.
So one of the things that comes up for this that we need to address is like, who are the women that we are talking about in these studies? And this kind of gets to a deeper thing about gender in general and what it means to do a study that is in gender. So when we're referring to women, we are specifically referring to the cis and trans females who were the specific subject of these studies. And much of the research that's out there is just kind of looking at that binary. So that excludes a lot of people that are considered statistically insignificant, but they are considered statistically insignificant largely because they are not being counted initially when they're being forced into either of these two categories. Some of the people in this study, as a result, may have been misclassified or misgendered due to poor survey practices, whether it's only giving two options, or there are certain studies that use machine learning techniques to go and scrape data and classify by names. And names can be ambiguous. That's also a very Western-centered idea of how you can classify people. And also, a person's name is not indicative of their gender. So that's another disclaimer there. And there's a citation.
So we know that the studies that we're going to cite, we know that they're flawed, but we're working with the material we have available because we still think it's an important discussion to have. Neither of us believe that looking at women as the only diagnostic of equity is a good practice, especially because there is no singular experience of being underrepresented or marginalized. A couple examples, gender nonconforming individuals and trans women have a much higher rate of workplace harassment than cis women. Women of color face a greater frequency of discrimination than white women. I mean, we could go on. The point being that every person deserves representation and equity and inclusion research. And unfortunately, that's not really the case right now. And I highly recommend that both this citation and the previous one, they talk about an aspect of this issue that is really, really important.
That said, we're doing the best with what we've got. And so we're just going to kind of give a little bit of definition as far as what it means to talk about underrepresented people in physics. And specifically in the case of most of these studies, what it means to be underrepresented is situational to the population. And in physics, by APS standards, underrepresented groups are gender minorities, which include cis women, trans, non-binary, and gender non-conforming people, domestic minorities such as African Americans, Latinx and Hispanic people, and Indigenous people, as well as LGBTQIA people, so people who are sexual minorities. There are other minorities that don't necessarily qualify as underrepresented, but may still face discrimination or harassment in physics. I think a really, really good example of this is a lot of the stuff that we've seen over the summer and currently as far as shortening visas or travel bans as well for a lot of our international students.
An important component of this discussion, of course, is that we all have privilege, and privilege is not inherently a bad thing. It describes a set of attributes which are beyond your control that society chooses to categorize people by. And these attributes can either help you or hurt you. So some of the things, some of these attributes that may give you privilege are race, ethnicity, sexuality, religion, gender, disability, citizenship, age. I'm sure we could list more. So one way to think about this is that these attributes can either increase or decrease your baseline HP. It's like a superpower. It can be used for good. So if you're, if you're in a position of privilege, you can help people who don't have privilege. It's also not a simple thing to measure, right? So there are ways in which you may have a ton of privilege and other ways in which you do not. So as a white person, I have a ton of privilege. As a woman, not so much, right? So it can be a really complicated question to consider, and it's also very situational.
Okay, so here's a couple of quick numbers. These are from 2017 from the APS website. We haven't updated this significantly, but this is still pretty relevant. So 21% of bachelors in physics went to women. 18% of doctoral degrees in physics went to women. It's a 2% drop across those, and this is in 2017. So Rutgers reported their numbers from 2015 through 2017, and we were below the national average. We graduated 19.3% for physics doctorate degrees, and we have 19.3% women who are in the physics degree program for a PhD. And is that right?
I think it's that the national rate was 19.3% of doctorate degrees going to women, but
I can't read.
It's okay.
We're at about half.
Yeah. So we're at half the national rate, and that's not good.
That's not good. Female astronomers leave the academic labor market 3 to 4 times faster than male astronomers during the postdoc stage. And that's from a paper from 2018.
Can I ask a quick question?
Yes.
So this number, like, how does it look when you compare like some of the top universities versus the slightly bottom, like lower ranked universities? Is it uniform? I mean, I didn't assume so, but can you tell me more about that?
I haven't. Charlotte, have you looked this up? Because I haven't looked this up. I feel like I've seen something where there is quite a bit of spread, but I don't remember seeing a specific trend.
Okay.
I have suspicions that it's going to vary, not necessarily based on prestige of the program, because it's going to be more anchored to the environment of the program. So
yeah, it's definitely going to depend a lot on the culture and the environment of a specific department.
Yeah, that's right.
So
okay, good. Thanks.
does have these numbers, so that would be a really fun experiment to do.
yes,
We just kind of look at.
I'm
Okay.
sure the information's out there. I just don't know where.
Yeah. So Andrea Ghez is only the 4th woman to ever win the Nobel Prize. So can anyone name the other 3?
I can.
Mary Curie.
Marie,
Okay.
one of
Yeah,
them.
Marie Curie, Maria Goeppert-Mayer,
Yes.
and Donna Strickland.
Yes.
There we go.
Maria Goeppert-Mayer is the one that most people don't know.
Yeah.
Sad.
She's a nuclear physicist, and so that helped me.
So you got it.
If we were giving out candy, you would get candy.
No, we're not giving out candy.
I wish we could. Anyway, yes. So let's get into specifics. So what are the factors that cause people to leave the field? So we've talked about, women and other underrepresented groups leave the field at a higher rate. So why? We're going to go through each of these in greater detail, but unconscious bias, stereotype threat, imposter syndrome, direct or indirect harassment, and external factors. I think we're not going to talk about direct or indirect harassment quite as much. Hopefully you know what that is. If you don't, please ask, we can talk about it. And I don't think we're going to talk about external factors either. We're going to focus on the first three. Of course, all of these things can be experienced by anyone, but are experienced with greater frequency by underrepresented groups. And all of these impact performance and mental health and can be heavily influenced by the behavior of peers, advisors, professors, mentors, etc.
Oh, I don't need to intro this. This is just a good one.
Yeah.
It's an example of stereotypes.
The two things I would like to say about this is, first of all, notice the date. So 1998, this has been going on for a while. And this actually bears a certain resemblance to my first year of grad school. So it's still relevant.
Mm-hmm. Okay. All right. So do you want to take this one or do you want me to?
I can. I don't know that there's all that much to say other than I haven't updated this since 2017, but I also can tell you that the problem has not been solved in the last 3 years. So I think it, for the most part, speaks for itself. Things are getting better than they were in the 60s, but you know, when you start at 2%, yeah.
Yeah, and there is actually like a downturn by 2017. It's hard to say whether or not that's just noise, though.
Yeah,
But,
I'm gonna hope that it's noise, but
yeah. Okay.
And that is a question?
Yeah.
Mm-hmm.
Why it looks like become just a flatten, right? The recent 10 years, 15 years.
I don't know.
There should be something.
Yeah.
Should not be saturation. Okay, I'm just curious.
Yeah.
Yeah, I mean, I don't like the fact that it's hovering at 20%. That means that we're not making the situation any better. I don't know.
So is there a similar trend if we plot for men as well, like especially after 2007?
I mean, this is a percentage of the total number of people getting physics degrees.
Oh, okay, I see. So then the
yeah,
men has
to mirror. So yeah. they will have started at like maybe 95, 97%, and then go down to
yeah.
Okay.
So I mean, it could be as simple as there are a lot more men getting degrees in the last few years, and that just to flatten off. But also, like, why are we attracting more men and not more women?
Exactly.
Also, this is definitely one of the sets of statistics where you have to take it with a little bit of grain of salt, because somehow I don't know how the APS is gathering this data, and they seem to only be splitting people into men and women. So obviously, there's a lot of issues with that particular study approach. And we can compare that to all of the other scientific fields. We're worse than engineering, people.
yeah.
It's worse than engineering.
We were beating them up until 97. It's pretty grim.
Yeah.
Yeah. So by breaking it down by STEM degrees, we're not looking good.
I also want to throw a side note out here, because this one drawback to this kind of statistic, I mean, looking at the numbers is great because it gives you a really concrete thing to point at. But like, if you look at something like earth sciences or biology, where they're around 50%, you would think, oh, it's fine, right? But this is only one way of looking at the numbers, right? This does not get at all of the other forms of differential treatment. You know, discrepancies in who gets the money, discrepancies in who gets authorship credit, discrepancy in who gets first authorship credit, you know, all of those things that are not reflected in things like the numbers, but still have a huge impact on people's experience. So I think that's worth keeping in mind, that this is not even this is not even the bare minimum, right?
Okay. I don't remember if it's me or you, so I'm just going to talk.
Go for it.
All right. So from Nature, we have some more numbers here. Women accounted for only 13% of prestigious last author spots. So this is getting at some of the other issues. The percentage has only increased by 0.1% per year since 2002. So very, very slow growth, which means that equity will be reached in only 260 years, which that's good. So from the New York Times, men get more federal grant money and male PIs received, 41,000 more than female PIs from the National Institute of Health. So this is more for the health and environment sciences there. So from AAUW, there's a 2013 study that says that pay for women in computer science, mathematics, engineering, and physics jobs, they were only making 82 to 87% of the money as their male peers.
So let's start talking about some of these contributing factors that we mentioned earlier. First up, unconscious bias. Let's jump right in the definition. Unconscious biases are social stereotypes about certain groups of people that individuals form outside their own conscious awareness. Everyone holds unconscious beliefs about various social and identity groups, and these biases stem from one's tendency to organize social worlds by categorizing. Unconscious bias is far more prevalent than conscious bias and often incompatible with one's conscious values. Certain scenarios can activate unconscious attitudes and beliefs. For example, biases may be more prevalent when multitasking or working under time pressure.
Okay, so there's actually quite a few studies on unconscious bias. There's one from 2012 where they did a randomized double-blind study and asked faculty to rate a student for a lab manager position. Students were randomly given male or female names, and faculty rated male applicants as significantly more competent or hireable. This is for identical resumes or identical CVs. So selected hires starting salary and also offered more career mentoring for male students. Gender of faculty really didn't have an effect. So this was across the board for all faculty. There was a preference.
A quick side note about unconscious bias. I think that it's also been pointed out recently that while it's important to be aware of unconscious bias, and it is more prevalent in conscious bias, that doesn't mean we shouldn't be worried about conscious bias too, because that also happens and has a huge impact. Anyway, moving on. Stereotype. So the next contributing factor that we mentioned is stereotype threat, which refers to being at risk of confirming as a self-characteristic a negative stereotype about one's social group. In general, the conditions that produce stereotype threat are ones in which a highlighted stereotype implicates the self through association with a relevant social category. And these are a couple excellent studies, and there are so many studies on this for many different groups. Yeah, so this the basic idea being if you're, a member of a group that is stereotyped as being bad at a thing, and then you're put in a high pressure situation where you're asked to perform well on that thing, all of a sudden you start feeling like you're representing that entire group and you can't possibly succeed. And also you're going to let down your entire group because you did poorly on this one test, even though you're perfectly capable and the whole thing is dumb.
So here's some numbers on stereotype threat. At the end of a year-long physics course in which women are severely underrepresented, agreeing with a gender stereotype was correlated negatively with the performance of female students on the conceptual physics surveys. So this was a study where essentially, they're surveyed after the course, and yeah. maybe partially due to students who agree with the gender stereotype having increased stereotype threat. There's an anecdote that really relates to this, where Mary James, who's from Reed College, which is Sabrina's alma mater, told a story of all of the, the constantly, girls were coming into office hours and being like, oh my God, I'm failing, I'm so bad at this. And they were getting better grades than the boys in the class, but they were having much more anxiety over, the small grade difference.
And we'll give you a link to her. So the talk that Charlotte's referring to is available and on YouTube, and we'll give you a link to it later and you should go watch it. We considered just replacing our entire talk with her talk because it's so good, but we didn't. So the third factor that we want to talk about is imposter syndrome, which is the persistent inability to believe that one's success is deserved or has been legitimately achieved as a result of one's own efforts or skills. So this particular study says, quote, believing that one's accomplishments came about not through genuine ability, but as a result of having been lucky, having worked harder than others, and having manipulated others' impressions. So one of the key things about imposter syndrome is that there's this sort of sense that, oh, I'm an imposter and somebody's going to figure it out and then they're going to kick me out of the program, and like it was a mistake that they let me in the first place. And yeah, and this is not going to be unique to underrepresented groups. Many people who are, very successful or very well represented in their field experience imposter syndrome. But I think, as we'll see on the next slide, it's more prevalent and can be a huge problem for members of underrepresented groups. Yeah.
So spoiler, women are more likely than men to show characteristics associated with imposter syndrome. Also more likely to report feeling that they have to work harder than others to succeed, and are less likely to attribute their success to their high ability, and less likely to report feeling confident in their ability to succeed in the future. Students who felt mentored were less likely to exhibit imposter syndrome. So there is, a bit of an antidote here, which is hopeful.
And a lot of these things sort of feed on each other, right? If you're the only member of your group in a particular setting, it's really easy to think, oh, clearly I don't belong here. This clearly was a mistake. And that, that feeds right into that imposter syndrome, and it just becomes this vicious cycle. So some more numbers. First of all, this study is titled, Female Students with A's Have Similar Physics Self-Efficacy as Male Students with C's in Introductory Courses, a Cause for Alarm? And I feel like that title just sort of says it all. But in case you want more, self-efficacy graphs grew over Physics 1 and 2 courses, regardless of course format and instructor. And female students' self-efficacy was negatively impacted by introductory physics. So our introductory physics courses are destroying these students' sense of self-confidence and ability in the field. And yeah, this is the anecdote that we were talking about, where this Professor Mary James reports having women with B's in the course come in and ask if they should quit, but has never had a male student do the same.
Yay.
I have a question about the last slide. Sorry.
Yeah.
So when talking about self-efficacy, what's the like metric that's measured by in this
I
context?
haven't looked at this study in 2 years. I don't remember exactly how they measured it. Do you, Charlotte?
Just out of curiosity.
Yeah.
I do not remember. I think that's a really good question.
Yeah.
Yeah.
I want to think it was some form of questionnaire where they were asking students something, but I don't remember. I'm sorry.
Yeah.
Definitely go look it up.
It could be just like a simple, questionnaire of like, are you good at physics? Yes or no. But I'm hopeful that it's much more involved. for this study. So.
So we're going to talk about some solutions and ideas, and if you have ideas of your own, please feel free to chime in, but these are some things that we were able to cobble together.
There we go. Okay, so individual solutions. This is basically, you know, what you can do if you are, you know, underrepresented in your field. So taking care of yourself, essentially, setting boundaries, learning to say no, like putting a premium on your own time and setting aside time to really take care of yourself and your needs. Mental health care, which is really prioritizing your own mental health and taking very seriously when you're experiencing stressors. Finding mentors and role models and connecting with them, because mentorship really does help with a lot of these. Reaching out and talking to colleagues that you can trust in your community, and trusting your gut on all of the little things, because those just kind of death by 1,000 cuts is never fun.
And if you are not underrepresented yourself and want to support someone who's underrepresented, or if you are underrepresented yourself and want to support someone else who is underrepresented, the best place to start is don't discount the little stuff. If you have a friend who had a weird interaction in class and they just need to talk about it, let them talk about it. Having that, you know, and this gets to the second point, right? Be a good listener. You know, you can do a lot by just making someone feel valued and feel like their experience is real and worth considering. Also, ask women and members of underrepresented groups about their research, not just about what it's like to be a woman in physics, right? Not just their personal lives. These are people who are also physicists, not just members of an underrepresented group. And so it's important to make sure that they, you know, we value that aspect of them as well. Also, mentoring matters. So, you know, give lots of thought to, if you're in a position of being a mentor, do it right, you know.
Okay, so cohort solutions, and this can also mean, like, you know, this can mean small groups. This doesn't have to be your entire cohort, because we all get lost from one another after the first 2 years, essentially. Be supportive of your peers, and that's kind of a vague statement. So listen, they need to talk, and doing that can mean a lot. Also having, like, you know, being able to, if somebody comes to you with a problem, or if you approach somebody and ask them if they need advocacy because you've seen something strange happen, be upfront with them and ask them what they need before they start talking about it. Be like, what do you need from me today? Like, do you need me to just listen, or would you like solutions that I may see? Would you like my advice? Because, you know, I think that sometimes people need advice and sometimes people really don't need advice. And so making sure that you're not on the wrong side of that is helpful. If something is weird, take it upon yourself to like approach that subject. You know, speak up, even if there's nobody around who would be necessarily negatively affected, because you can make a difference.
Also, side note on both the cohort solutions and individual solutions, if you feel like you don't know very much about these issues, educating yourself means a lot, whether that's going out and you know, looking up these studies and teaching yourself about these issues, or if that's just being, you know, asking genuine questions of your colleagues, right? If you know someone who's underrepresented and seems to be struggling with something and you don't understand why, being genuine and wanting to learn can mean so much. I had a friend in undergrad who did that, he didn't understand something and asked very genuinely, and it made me so happy and made me trust him more, because he was willing to admit that he didn't know something and wanted to learn about it. So that can have a big impact too. And of course, there's departmental solutions. So diversity and inclusion policies and or anti-harassment policies are huge. Code of conducts are huge. Department-wide unconscious bias training is important. Also, just generally being able to discuss problems openly. So having things like this S-bar makes a big difference because it means we can all kind of talk about these issues. Also having groups directed towards supporting underrepresented minorities. So we have MIPA, which is the Minorities in Physics and Astronomy group. I'm the graduate chair. Please add yourself to the mailing list if you want to learn more about the things that we do. Ask me about it if you want to know more about it, that kind of thing. And if you have a leadership role in a department, it's really important to speak up about visible problems within and outside of your department. And as always, mentoring matters, and mentoring well matters. You can turn somebody's, you can make somebody's time in grad school or career or whatever possible and wonderful, or you can end it through good or bad mentoring. So.
Oh, all right, nuclear physics. So Chad's going to recognize some of these people. So this is an example of, making an impact. There wasn't actually a women in physics dinner or anything for a really long time during the DNP meetings. And so it was actually a student from Rutgers and her advisor that kind of put this together. So this is the very first year that it happened. And so that's a nice group. Here are consecutive years afterwards, and the numbers have just grown, and it's now a nice established thing and really good community building. So yay.
So now we're going to get into the scenarios. This is the link to the talk on YouTube by Mary James that we were talking about. It's called What Does Access Really Mean? It's got a lot of really wonderful stories from her experience as an African-American woman in physics, and a lot of really great advice and ways of thinking about these issues. I highly recommend you watch it. It's great. And you might spot Charlotte and I in the audience. Side note. Charlotte, maybe we should pop this into the chat in case people want to open the link, and then we should probably stop recording so that we can
move on to scenarios.
Move on